All right, good morning, everyone. Welcome to this session, the Forum 360, entitled A Systems View of Sustainability. I'm Phil Ansell. I'm an associate professor of aerospace engineering at the University of Illinois, and I'll be moderating today's discussion. We are fortunate to have a great program here for you today. So these panelists are wonderful, so looking forward to hearing more from them. But prior to giving these introductions, we wanted to first lay out a little bit of background to kind of pin this discussion this morning to say what really is sustainability, what's a systems view of sustainability, so that way we can take that moving forward and make progress as a community. So in my vast spare time, one of the things that I do is I direct our Center for Sustainable Aviation. And in collaboration across a number of different people, individuals involved, we have spent a lot of time developing what is our definition for sustainable aviation. So you can see it here. The air transportation system that maintains the connectivity of communities and mobility of people, goods, and services while minimizing negative impacts to human health, fostering productive quality of life, and conserving terrestrial resources. Now, the interesting thing here is that if we consider what I like to sometimes call the capital S sustainability, right? This is an entire field and community that transcends aerospace. Typically, this sustainability question is supported by three pillars: environment, economy, and society. So for the first one, the environment, we as a society operate a global air transportation system, which is wonderful, but also the fact that we use petroleum-derived kerosene fuel as our energy carrier means that we have greenhouse gas emissions associated with the aviation sector that contribute to climate change. Pursuant to sustainability, I will talk a little bit later about how important energy is in that process, but the affordability of sustainable energy is one of the critical elements to maintaining a future sustainable aviation ecosystem. So the economic viability is really needed to ensure the longevity of this industry. And you can see historically over the past couple decades how this has been a challenge for aircraft operators. And turns out it's actually very difficult to maintain a profitable airline. So interesting fact. So given the fact that we're interested in pursuing economically sustainable aviation ecosystem, it's also interesting to note that aviation actually catalyzes economic activity globally, even outside of just the direct impacts of creating aircraft and flying them. However, aviation has a distinct role to benefit humanity in prioritizing societal well-being. And so this is one of our tenets to sustainability that often is overlooked. Not everyone has equal access to aviation. There's common links between socioeconomic status and your flight activity. Aviation also contributes to particulate matter emissions, for instance, that has toxicological properties to human health. How do we approach these as a community and maintain humanity in its priority of the future of the field? So with that definition in mind and the three pillars kind of set up, it's important for us to now establish maybe a framework that we can use as a launching point for future developments. So if we're creating a framework, it's kind of important maybe to start with the goal in mind. So let's start there, right? We have a sustainability goal at the left-hand side and the outcomes on the right-hand side. So what fills in the middle? Well, aircraft today operate in a broader transportation network. So you can kind of see that lower tier in orange of the transportation networks. And so aircraft are not just in their own individual vacuum. People are coming to airports from cars, trains, buses, et cetera. And that transportation network of the future is going to largely establish what the markets and routes and demand need cases are for the future. And to be able to actually conduct those operations, we are going to need maybe a similar or dissimilar infrastructure and supply chain. So operations are great, sustainable operations are great, but it's kind of hard to do sustainable operations without sustainable products. So on the upper tier here, where we have kind of the product development capabilities, critical to that process is being able to get clean energy onto the aircraft. Obviously, aircraft cannot operate without energy. And the next step, of course, is to convert that energy into power. This is basic physics, right? We all did this in kindergarten. I'm kidding. So power and propulsion systems, very important to maintain sustainability mindsets as we develop and mature those technologies. And then we wrap an aircraft around this that meets the range, endurance, passenger capacity, payload capabilities with the use of that propulsion system. And then in purple, just downstream of that, we end up having now the actual aircraft flying through airspace, impacting the environment, impacting society in various ways. From there, then, we can measure how well did we do and reassess. And it's important to indicate here that sustainability is an evolutionary process. Air transportation today is very different than it was 100 years ago. So we, as a society and a community, also need to be flexible enough to evolve with the sustainability needs of this area. So this is a nice, clean framework, right? It's simple. It's something that we all can kind of understand and comprehend. When we get into the nitty-gritty details of it, and this is an eye chart, right? So you can kind of tell that it's really meant to be more conceptual than anything else. There are so many individual facets within each of these little bricks that each stakeholder holds dear to their role that it's very complicated. Maintaining a system-level view at the top down is very important, but also we need to make developments from the bottom up and have these developments be interconnected across our ecosystem to a greater extent than we ever have before. So therein lies the challenge. So what do we do? Well, I think important to this is to do what I call instilling sustainability thinking for the future. And this has three parts. The first is to understand sustainability, which requires interdisciplinary perspectives, and you'll hear some of those today, of aviation's impacts. Second is developing sustainable aviation requires a holistic view of the integrated vehicle, aerospace product, the energy life cycle. And the third thing is achieving sustainable aviation requires unified goals that evolve with our knowledge and technical capabilities. So that should kick off our discussions today. Thank you very much for your attention at this kickoff. And Dr. Oldani, would you like to start by introducing yourself?
Sure. And good test of the mic. Well, thanks, Phil, for that wonderful introduction. I really enjoyed the slide where you actually broke down everything, because it's great to talk about things at abstract, high level, but seeing the details of what we're actually talking about when we mean some of these concepts is important. So for those of you who don't know me, my name is Oldani. I am the Chief Scientific and Technical Advisor of Environment and Energy at the Federal Aviation Administration. So we're part of the Department of Transportation. It's always helpful to remind people of that. AEE, our office, as we abbreviate it, is within the office of APL, which is Policy, International Affairs, and Environment. So it's a bit of a unique part of the FAA. I think a lot of you are probably familiar with aircraft cert and safety, airports, really those sort of fundamental pieces that make the aviation ecosystem work. We're really lucky in the office that I work in, because not only are we working with those organizations, with those offices to understand their needs and their challenges, but we also then take that next step of the ecosystem, right? So looking at the broader sustainability, what policies do we need to put in place to make sure that these new technologies actually make their way into the field. So really lucky to be in the area that I work in, and really looking forward to this panel discussion.
Great, thank you very much. Sangita, would you like to introduce yourself as well?
Sure. Good morning, everyone. I'm Sangita Sharma, and I work at Delta Airlines, where I lead the Sustainable Skies Lab. This lab was established last year to help deliver our sustainability vision, which is net zero by 2050. If we go to the next slide, net zero by 2050 is a big, hairy, audacious goal. You don't reach that without clear interim measurable milestones. And so I've thrown up our roadmap on this slide. And I'm not going to go into it in great detail, because I think we've got a whole panel to talk about the challenges ahead of us. But what I will say is, one, what we've learned at Delta is that sustainability is a business imperative. Our customers are asking us to do this. Our employees are asking us to do this. Our shareholders are asking us to do this. And secondly, these challenges are ones that we don't have the answers to by ourselves. And so that's where the lab comes in, to partner with academia, external industry, and divisions within Delta to internally give the message that every job should be a climate job at this company, but externally help solve some of these challenges. And I am much less eloquent than Viola Davis, so we have a short clip to play. If you flew Delta on the way here, you may have already watched it.
No one sees the world quite like an airline. But the world we see below us every day is changing. Fast. That's why Delta is committed to net zero carbon emissions by 2050. It's why we're partnering across the industry to create the future of aviation. And switching ground vehicle after ground vehicle to electric. It's why we're accelerating our push to source sustainable aviation fuel. And it's why we're also getting rid of 4.9 million pounds of single-use plastics annually. That's just what we're doing. But it'll take more than just the 90,000 of us at Delta. It'll take everyone, at every airline and in every industry. Because we know a thing or two about getting where we need to be. And it's time we all got going. Together.
Great, thank you for sharing that. Love the clip. Dr. Shyne, your turn.
Yes, good morning, everyone. My name is Rickey Shyne. I'm Director of Research and Engineering at NASA Glenn Research Center in Cleveland, Ohio. And so one of the things that we get an opportunity to do at Glenn is we get to touch upon power and propulsion. Those are two of our core hallmarks of our core competencies. So when I look at that as it applies to sustainable aviation, it looks at everything from looking at sustainable aviation fuels, electrification, so the batteries and the power systems, and that's where Phil and I have spent a lot of time talking about that, whether or not we can make the investments that are required to look at hydrogen as a alternative fuel, and all the ramifications of that. Are the new material systems that need to be developed in order to be able to use hydrogen consistently and be able to use hydrogen in a way that's really very sustainable, especially for the industry. And then when we start looking at structural systems, are those things that we can do structurally, looking at the aerodynamics of the aircraft, and be able to change the way that we design and utilize aircraft as part of that sustainable ecosystem that we're looking at. And then the last thing, which is something over the last probably 6 months I've become very interested in, what is the full life cycle of what we do with these new systems that we're talking about bringing in? If we're talking about more electric aircraft and using battery and fuel cell systems, can we design those systems up front in a way that allows us to be able to either repurpose or recycle or reuse components or either significant portions of a battery or fuel cell system as we move out into the future? And so one of the things that I tell people that's NASA's major contribution to this is providing that fundamental research and technology that's going to be required to allow some of these sustainable aviation goals to be met.
Very good. Wonderful message. And last but certainly not least, our recent award winner, Amanda Simpson. Would you like to say a couple words about yourself?
Well, thank you, Phil. So Amanda Simpson, formerly with the Department of Defense, where I ran the energy office there for several years, and most recently with Airbus Americas, where I ran the innovation office there. Now I'm off on my own, so all the opinions I say are my own, which is great weight lifted off my shoulders. But it's interesting to think about sustainability, and I without going into the minutia, Phil, and an educator's got to educate. I get that, but when you look at it, a balance between the environmental impact, the societal impact, the economic impact, and you think about the history of aviation, and when aviation was in its infancy, it was all about speed, right? It was about getting there faster, and we were willing to pay for that, both economically and environment. We didn't even think about the environment, right? So that's what we did. We just got faster and faster and faster until the point where it became, maybe we need to be thinking about it, the economics of it. And so the focus kind of shifted from getting there faster to how do we make it economical? How do we open it up for everyone, right? And make travel more affordable. And we did that really, really well. And now we've shifted we're beginning this shift to look at the environmental impact. But we can't ignore the others because they drove where we were to begin with. Aviation's always going to be about speed. It has to be economical. But now how do we balance the environmental impact? So when we think about things, we think about electric aircraft or advanced air mobility. Where's that electricity coming from? We're paying a price. Advanced air mobility is not an environmental, does not bring environmental service to aviation. Anytime you go faster, you're using more energy. Where's the energy coming from, right? Now we're at the point where it's about convenience, right? Someone asked a question earlier in a private conversation I thought was great. If you could fly across the Atlantic at Mach 2 or 1.7, but you're in a cabin like this for 3.5 or 4 hours, would you prefer to do that and pay a lot of money? Or would you prefer to make an 8-hour flight where you're in a nice comfy seat or maybe a lay flat bed and you get Wi-Fi service and you get really great food? Maybe you would even be willing to do it in 10 hours if they pulled the throttle back 10% and you just enjoyed your time on the plane. It would be more economical, it would be more environmentally sensitive, but it wouldn't be as fast. So we have to kind of balance what we need to be thinking about as we move into this environmental sensitivity phase of aviation. So it's kind of an interesting way to think about how we've made that transition over the decades.
Very good. Yeah, appreciate that perspective. So as I guess we kind of consider, the title of this this session and AIAA's theme for this SciTech forum, outside in, expanding the boundaries. What does the system level look like as far as all of you are concerned? How do you view system perspectives towards sustainability, and why is it important to maintain those perspectives?
Should I kick us off?
Go for it.
So sort of in my intro, I was leading into the fact that, the FAA is a very broad organization and there's many facets to it. And I think part of the benefit of being part of such a big organization is that we really are able to see all of the different pieces that need to come into play to make it a truly sustainable aviation ecosystem. I was at a meeting maybe a year or two ago, and they were drawing their system boundaries around the technology that they were focused on for this particular meeting, noting that there are other elements that have to come into play to make that technology work, but we're not going to talk about those other elements. And as others have noted, it's not truly sustainable until those other elements have come through and have also are part of that sustainability equation. So I think at the FAA, we're very much aware of that. We're very much focused on not just the technology, making sure the technology is safe, right? First and foremost, we need to make sure that the new aircraft that we're certifying are safe to fly. We are going to meet current or exceed current standards. But once we have that aircraft that is safe, how about the airport? How is the airport safe, right? If we're talking about new energies and new fueling infrastructure that we'll need, we need to ensure that that can be delivered safely. And now it's getting delivered safely, but how is it being made? Is it being made safely? Is it being made environmentally friendly in an environmentally friendly manner? Is it being made with fair labor rights? And all of these things that have to be part of the situation, it can seem overwhelming. And I think at times, it can be frustrating if you back off too much. We definitely need still the focus on those pieces, because I think sometimes if you back up too much from the picture, then you're not actually getting the work done that you need. But I think it's important in any aspect of this entire ecosystem that you're aware of the other parts that have to come into play, because you might be able to produce a great technology, but then you realize that the other pieces that you needed aren't there yet. And so what have you really accomplished? And so I think it's important at our organization, at the FAA, what we really try and make sure is that we consider holistically the points that you've already raised, not just talking about the environment, we're talking about economically, is it financially a win-win? Because industry is really not going to do it unless it makes financial sense. And so we have to find those opportunities where it does make financial sense. And I think one good example of this, right, is fuel burn. That's an easy win-win, right? The less fuel you burn, the less cost you have for fuel, and the less emissions you're going to be making. So finding those types of opportunities where industry is going to benefit from an economic perspective, the environment is going to benefit, and then socially ensuring that we can keep going, right? Sustainability is able to sustain. How can we make sure that not only aviation endures, because I think we all appreciate aviation for many different reasons, but that the planet endures and that people can continue to endure too as well. So I think overall, we're really focused on all the different pieces of it, and I feel that we have a lot of good programs in place, but it's important to keep coordinating with the people that are focused on the details so that we can remind them, hey, you got to talk to this person, or you got to work with this organization.
Interesting, thank you.
Yeah, no, I appreciate what you say, and I think about it as the power of and, right? Every airline's mandate is to operate safely, cleanly, reliably, with elevated service, and now sustainably. And it's really, where do you find those and synergies and invest in those first so that you gain momentum? When we think about sustainability at Delta, it really boils down to, I think, three basic questions. What are you flying? How are you flying it? And what's the fuel you're using? And I think for each of those, you can think about it at a systems level, right? What are you flying? Are there revolutionary fleet we should be investing in and understanding? What are the infrastructure implications for that? This is a room full of aerospace engineers, so I can talk about aspect ratio. If you increase the wingspan, you get better aspect ratio, but it may not fit into your gate anymore. And that's a problem, because if you only have one gate that's compatible with your airplane, you're probably sitting on the taxiway for a long time, and you're about to get 30 angry customer emails. We don't want that. There's also a huge workforce question, right? How do we train the workforce of tomorrow today so that we're ready when these technologies are ready to come online? And you can think about those questions, not just for what we're flying, but how we're flying it, how we're operating on the ground today. To Anna's point, saving gallons of fuel is economically a good thing to do. And so we're looking at everything, whether it's electrifying ground equipment or rolling out programs to help our ground agents understand to keep those APUs off while we're at the gate. And then again, it's the fuel you use, and how do we create signal demand to create more supply of those sustainable aviation fuels.
So from a systems perspective, and the reason why you really have to think about this, if you think about what Amanda talked about us saying flying slower or flying faster, the implications of that is now you're going to have to change the way that you manage the national airspace system in order to accommodate that. So if you don't think about it from a systems, this large perspective, then you can be developing this technology that then becomes incongruent with the goals that you really are trying to achieve. Secondly, when you think about from a systems perspective, so I mentioned hydrogen. So if we're going to do hydrogen, how does that change the airport infrastructure? How does that change the way that we have to train people to be able to handle hydrogen safely? How do we produce hydrogen? Again, the way we produce it, it takes energy to produce it. So how do we produce that in a way then that also supports what we're trying to do on a much larger level as far as sustainability is concerned? And so a lot of times we look at technologies as being these individual discrete technologies that we go and we develop, and that's great, but we also need to look at how does that fit in the larger picture, and that's why I think we always need to have this systems view of, if I change this technology, it then impacts this, all the way through the whole continuous airspace system, and then be able to make some evaluations on whether or not if the technology is really a really viable solution for what we're trying to achieve.
I love it, and I'm sure, Amanda, you have a lot to say about integration.
Yeah, well, and I want to think about, when you look at the overall, right, the ecosystem, is so who's driving it, right? So who's the responsible parties that are saying what is the priority? right? Sustainability of the aerospace ecosystem is a societal issue. Are we then, so who are making the decisions on what are the priorities? Is it the airlines? Is it the manufacturers? Is it the agencies that are looking at the new technology? Is it the political landscape who are making the decisions on where the funding is? Is it the flying public who are voting, so to speak, on where they complain? It's noisy, I can't get the direct flights that I want. Remember, a direct flight is always gonna be more sustainable than the hub and spoke system. So who's kind of pushing the priorities? I mean, that's something one has to really kind of take a back step and look at. And then the question is, who's paying the price? Right? How do you evaluate the environmental impact? I mean, I think for anyone who read any of the papers this morning, 2023 was the warmest year on record. And not by a little bit, by a lot. I mean, if you look at the graph, I think the New York Times put out of, here's where the month-by-month average temperatures across the US and across the world, and then here's 2023. It wasn't like a little bit different. It was way the heck up here. We don't assess that cost. And we don't know how to assess that cost. So until you figure out how to put that factor into our planning to whatever net zero means by 2050, that net zero emissions, net zero carbon, how much of the, where are you drawing the boundaries around the ecosystem? Does it go all the way back to the, quote, well to wheels? Is it, where are you drawing those boundaries? Those are all these kind of questions we have to decide upon. But we have to understand the value and the impact of what's going on. And if we're going to have, and I thank you for mentioning this, if we're going to have a ecosystem that is sustainable, not just an environmental, but a societal standpoint, where's the workforce coming for the future, right? It's not just the people who are gonna handle the new technologies, it's the pilots, it's the maintainers, it's the engineers, it's everything from gate and ramp agents to, the entire ecosystem is massive. And when you look at the projections of 3 to 4% growth per year, we're doubling operations or the number of passengers that are moved in the next 15 to 20 years. We're tripling it by 2050, triple what it is today. How do we absorb that growth, plan for that growth, and still do it in a responsible fashion? One way to think about sustainability is we use our resources today without jeopardizing their availability in the future. And that's energy, and that's also humans. So we have to think about all of that today to plan for an uncertain future.
That's a wonderful insight. I guess, some maybe challenges that we see from kind of our roles in the aviation ecosystem. And, Amanda just had mentioned about increased volume in energy demand. So energy is, as we, I think, kind of covered, and certification, of course. You can't do aircraft flight commercially without those two things. So Anna, I guess, what are some of the challenges that you see associated with developing sustainability in a system model?
Well, I think Amanda sort of just touched on it. I really wanted to sort of keep the challenge brief. It's really the scale up, right? So we talk about, and I use this statistic too as sort of a way of saying, well, aviation's only 2 to 3% of global CO2 emissions. It's really not that much. Like, we're putting billions of dollars globally to reduce and decarbonize aviation. That's, there's a fraction of people around the world that have actually flown, right? Billions of people have never flown before. As Amanda was saying, in the next few decades, we're expecting dramatic scale up. More people will be flying, many people will fly for the first time. I think the statistic was there's only 1% of aviation travelers that actually contribute 50% of our CO2 emissions, right? So the frequent flyers. And we want to ensure that we can fly in the future, right? And not to say that if there are other modes of transportation, I know we all love aviation, but if there's other modes of transportation available, by all means, we should be making use of them. Rail is a great option. But as we see the dramatic growth over these next few decades, and if other sectors of the economy are able to decarbonize, which we're hoping they will, aviation could have up to a quarter of global CO2 emissions by 2050. And that's significant, right? And so that's why there is so much pressure now for us to start making those changes, because we can't just wait till 2040 to start doing things for 2050. We got to start doing things now. And so the magnitude of the challenge, I think, is sort of finally starting to sink in as we see the projections for other parts of the world and how they're planning on starting to fly. And by all means, we want to ensure that they can do that, not only safely, right, because this a huge growth in just the number of new passengers and enplanements that we'll be expecting, but how we can do that sustainably. And so that's why we're really pushing now to take action so that by the time we're at 2050, we can have hope that we've actually scaled up not only some of these technologies, but just the way we implement them and ensure that we've taken into account some of these indirect effects that we might not be necessarily thinking about directly when we develop them.
Ah, yes, unknown unknowns.
Yep.
We'll get you. I'm curious, actually, Sangita, also for your thoughts on this, given the fact that, there's a lot of pressure for now also, not just, how are things going to change in the future. So what are some challenges that you see in your role?
You're spot on. I think 2050 is less than 30 years away, and that sounds like a long time, but it really isn't. And so the pace of technological innovation, and then to your point, the scale, are real challenges. And I'll talk about, again, the fuel side of the equation, SAF, sustainable aviation fuel. 2050, SAF will be a very important lever to reach that goal. But we have interim milestones as well that we're aiming to meet. 10% of our fuel usage should be through sustainable aviation fuels by 2030. And the supply is not there right now. I like to joke one of the most prolific feedstocks for SAF right now is, fats and used cooking oils, and we just don't eat enough French fries to fuel aviation. And so we really need to be thinking about what are those next generation feedstocks? How do we accelerate the development of these technologies so that we can have safe fuels at scale that are economically viable, so that we do continue to fly for the next 100 years, and so that flight is accessible to larger and larger swaths of the population.
And so that we can do it in a healthy way and don't require people to eat a lot more french fries, right? Because that's part of that.
Right.
Societal outcomes.
Right, exactly. As much as I love a good French fry, yeah, we need to be looking at renewables.
Very good. Well, also, if we kind of look at today's aircraft, they might stay in service for upwards of maybe even 30 years. And
absolutely.
Yeah, that's right. And so with that fact in mind, and the fact that we need to develop technologies that go on those future aircraft, I'm curious, Rickey, for your perspectives maybe on challenges in the technology development pathway associated with developing these new systems.
I think part of the challenges that we have is having consistent funding to do the developmental work that's required. So if you look at new materials, mostly new material systems take somewhere maybe 10, 15 years to develop. With some of the AI tools now, with some of the computational materials modeling, we're doing it faster, which is good. But then you still have to be able to get to a point where now you can produce it in scale and then be able to get it certifiable, okay, for those particular uses. And so when you look at the time lag in between when you have this great idea, say about a new material system, and then when you can finally get that to a point you can put it in the product, it could be significant, and it may not necessarily align with some of the goals that we would like to have as far as being introduced into the fleet to have the kind of impact that we want. If you start looking at, again, energy systems, whether it's a battery or fuel cells, we know what current state of the art is. We know we have challenges with lithium ion, okay? Great technology, but it has limits. So what's gonna be the next material chemistry for battery systems that's going to significantly increase the energy density? But at the same time, It can help us solve some of the issues as far as supply chain, because we know there's only certain places you can get lithium in abundance, and lithium is at a premium. So are there other chemistries now that we can start using and utilizing that allows us to be able to get away from that? Are there things that, again, that are unexplored at this point, but they have significant potential? And so when I think about all of those different variables, then to me, the one consistent theme that comes back for me is that, are we going to have the attention span to make sure that we provide adequate funding to allow those breakthroughs to happen? And typically, I know within especially the federal government, our attention span is not that good. We have these peaks and valleys as far as investments. And sometimes now, especially when we don't get the return on investment as quickly as we would like, then we want to move on to the next thing where we really haven't given it sufficient time to be able to grow and develop. There's certain things that people were talking about. The United States has been doing hypersonics since the 50s. But what's happened over the years? We lose interest, and then we go on to something else. And then we'll say, okay, it may not be a need for it now, but now we see what's happening globally, and especially on the military side of it. And we say, well, we need to be doing something more significant with hypersonics. Well, if you look at the fits and starts that we had in hypersonics technology since the 50s, if we would have consistent funding, a lot of the things that we're trying to do now, those things could have been developed years ago, but we haven't had the focus and the consistency in our research activities to make it come to fruition.
It's a wonderful insight. Thanks, Rickey. And I know, Amanda, I liked how you put kind of the pivoting or the kind of evolution to now including this environmental component and how we think about aviation. And I know you've thought about this quite extensively, but from a system level, what are the key challenges associated maybe with these grand transition plans that we have for the industry?
And I think, the panel's done a wonderful job of kind of highlighting them, right? How long, we think that 2050 is forever away, whether it's 30 years or some time in the horizon. I mean, when I was young, I thought the 21st century was forever ago, and now here we are almost a quarter of the way through the 21st century. Think about that. You want to talk about how fast time seems to be passing. So 2050 is right around the frickin' corner. You mentioned hypersonics back to the 50s. The Air Force flew a hydrogen-powered bomber in the 50s and then abandoned the project. And so here we are looking at hydrogen once again. So the consistency, the ability to say, if we're going to start on something that's going to make not just a beginning to make an impact, but a substantial impact by 2050, you have to start backing that up. And quite frankly, if we were to start on something today, right, it's probably a decade or more before it's actually being introduced into our ecosystem. And that's now you're in the 2035, and then you have about 15 years to ramp it up to actually make an impact. So when you look at some of the air Transportation Action Group, AIAA plans on how to get to net zero by 2050, you see SAF has a huge component, but you'll never get there with SAF because you're still putting carbon dioxide and carbon monoxide and sulfuric oxide, nitric oxide, and all those, quote, greenhouse gases in the environment. So then you say, well, what about fleet renewal? That's really important. The 80% of the 4,000 airliner fleet today are of an older technology. The new aircraft coming off the line today are 15 to 25% more fuel efficient right off the bat. So that's important. Operations, we've talked about lots of different ways, operations. It's always that 0.1% that you look at here and there and everywhere else that actually adds up to something real. And then there's that technology wedge, right? And whether it's new propulsion technologies, whether it's just new materials, new airframes, all that is at least a decade or more away, and that becomes a significant wedge that you have to apply. And if we don't start on it yesterday, we're not going to get there. So that consistency, the ability to think beyond the quarterly profits or the annual budget reauthorization is a challenge that we have to figure out how to circumvent. When John F. Kennedy said we were going to go to the moon by the end of the decade, somehow we actually stuck to that goal and did it. And that took, that was over multiple administrations, and it became this overwhelming effort by an entire nation to make that happen. And until sustainability becomes, aviation sustainability becomes something that we all embrace on a national level, it's not going to happen. We're seeing it in ground transportation with electric vehicles, but an electric vehicle today is dirtier than the gasoline-powered vehicle it replaces because of the source of the energy, because of the materials necessary for the batteries, because the vehicle is twice as heavy that you're moving around, right? But we have to figure out what's this revolution that's going to happen. We talk about aviation's the 3 to 4% of emissions today, could be 25% in the future. Today, concrete is 7% of emissions on an annual basis. But they're looking at how to make Portland cement by not using furnaces that are gas-powered. You can go on and on and on down the line, and if aviation, which is the slowest to make change, the hardest to decarbonize, if we don't start today and make it not only a national but international effort, we're not going to get there. So it becomes down to a social will.
Very good. Well, that tees us up actually for, I have one last question that I wanted to kind of just, expound on a little bit in the interim before we take some questions from the audience. So feel free to request some now or as we're kind of working through the next step here with this panel. But to the point of, okay, we need a concerted effort. What steps actually does this community need to take to advance the industry towards sustainability? We'll just maybe go down the line.
I'll kick us off again. Yeah. Well, I'll start with some of the topics that have come up recently of that consistency, that focus. We talk about the budget. As an example, so our office, typically we have pretty healthy, our budget line item for environment and energy, 60 to 80 million. In the House budget that came out, whenever it came out, various iterations, they actually had completely zeroed us out, which we don't take seriously. We feel confident that we'll be able to get our budget renewed, but it's going back to that point of consistency and focus. And one of the things I think that we've benefited from is going back to what I was saying about a win-win situation with sustainable aviation fuels, which my background is sort of more on the sustainable aviation fuel side. It is seen as something that generally has strong bipartisan support, right? So it's something that not only the environmental community can get behind if we can demonstrate that these fuels are truly sustainable, but it also has those domestic rural economic development opportunities, domestic energy security. We all know that these are key pieces that we care about as the world continues to evolve as it does, and the challenges that we continually face year in, year out. So I think one of the things that as a scientific community that we can continue to do is to really communicate the importance of these needs, right? We don't know what we need to be working on unless the people who care about these things express that these are the things that we need to be working on. I think sometimes being in a sort of siloed bubble, however you want to describe wherever you're working, you may think things are really obvious, and of course we would do this, and why not? But until you actually go out and meet people who are not working in your field or who may not have your same background or may not have your same resources, right? That's something I think, especially in sort of the federal area that we work with, when we go internationally and work with other countries and try to negotiate with other countries, we can't expect that they're going to come to the table with the same assumptions that we do, because they have different priorities, they have different natural resources, they have different concerns for their economy and society that they're wanting to bring in. So I think until you can not only express the things that are important to you, but actually take the time to understand what those important pieces are for the other communities where you work in. It might not be other countries, but it might be, the other departments at the university, like what are the things that they're working on? Just having that communication, I think is really important so that the legislators, the funding, all of that can then trickle down because it takes time. It takes time to actually go in and get those community needs expressed, and then to have that actually feed back into the hopeful funding that we get to continue the good work that we do.
Yeah, if you would have told me 10 years ago that I would have regular discussions with corn farmers in central Illinois, I'd think, what are you talking about?
Yeah.
But it's happening, right? Sangita, your perspective on what we need to do.
I mean, similarly, what are airlines doing talking to corn farmers? But we are. I think, you touch on kind of international priority. There are 50-ish national elections in 2024, and that brings turbulence, that brings prioritization challenges. And we've just spent the last 20 to 30 minutes talking about how challenging this is. This is a hard to abate sector, so I won't belabor that point. But I think said differently, it's opportunity. It's opportunity for innovation. It's opportunity to solve challenging problems. I think that's something that resonates with every single one of us in this room. And so it really boils down to partnership. How do you find the right people and partner to solve the right piece of that puzzle, keeping the system view in mind, so that we can actually get there?
Very good. So partnership, consistency. Rickey, anything else to add to the table?
Yeah, we talked about this earlier, but it's budgets and it's funding. And one of the things that I've come to realize is budgets are a reflection of what you value. So if it's important to you, you should ensure that the resources are reflective of that importance. And when we don't receive consistent funding to be able to support the things that we believe are important, then it really is not important to you. And so consistent funding, that being reflected in the budget, regardless of who's there or who's in control. As Amanda said, if it's a national priority, it's a national priority regardless of what administration is in. And then if it is a national priority, then that becomes then part of the budget cycle, and it's reflective in that because of the funding that's being expended to make that work come to fruition.
Kind of makes me wonder how far along the curve we could be if we just had continuity and funding and didn't have to spend time and energy stressing, right? Where is the next, project going to come from? Anyway, Amanda, sorry, I jumped in.
Well, no, and to tie kind of all that together, to get that consistency, and if that really is an issue, yes, the funding will come, and yes, all these priorities, but it's not, right? It's not that national priority. It's not something that is the funding is coming from or that the priorities are coming from because there's not this need. We used to say that you think globally and act locally. And so the issue becomes one of how do we get, to reverse it, how do we get people on the local level to understand the impact of what we're talking about today, right? Because until the leadership, and whether you want to call that, in the government or in corporations or even in educational institutions, understand that this is something that needs to be addressed today and not in the future, we have to build up that people need to understand the impact on their future or their impact today. I hate to say it, thoughts and prayers, or I could just basically say my concerns are with the people in Peachtree and DeKalb County this morning, which had tornado warnings, in January. Climate is changing. We see weather impacts and we go, well, the weather is not related to climate, but it is to some extent. So how do we make that people understand the tie between what's happening You know, the flooding that you showed in your video, the tornadoes that wipe out parts of the Midwest. How do, you know, the snowstorms that are hitting, how do we tie that into we need to do something, our society needs to do something about it, and we need to start now, we need to set that as a priority. We haven't made that connection yet, and that's kind of the key that has to happen if it's going to flow up so that we actually get movement on this topic. Significant movement on this topic.
Yeah, well said. Okay, well, if that doesn't put urgency to the matter, well, I don't know what else we could do. So with this in mind, we're going to transition to our Q&A session from all of you. So feel free to log into the Conference.io app, and not only can you ask a question, you can also upvote, so you can say, hey, I like that idea. Maybe we should talk about that. So to kind of kick things off, there's a really interesting one here. And so if anyone's out there and wants to launch a new journal, there's one that I've wanted for years, which is called the Journal of Null Results, right? Sometimes you learn a lot more based off of what doesn't work versus what actually works. So with this in mind, the question here is, what efforts in sustainability has the industry learned and pivoted away from? And on the other side, what are some untapped opportunities that might be in the horizon? And it's open to anyone who wants to take it. This is kind of a everyone, all, you know, free for all.
I think there was a traveling museum that was open in DC this year. It was the Museum of Failures, right? It was commercial things that just didn't work out. And I didn't, unfortunately, I never had the opportunity to go visit, but the concept of understanding where people have put effort that didn't work, and how do we learn from that, right? Our industry was based upon failures, right? We have an incredible safety record because of failures. You know, our safety record has been paid for by incredible number of lives. And how do we respect that? You know, we do. We've learned from that on a safety level. But how do we then do that same thing on a sustainability level? You know, safety is uncompromised in aviation. You know, I think you've heard that several times this week. And I think we all believe that. But how do we make sustainability on that level? How do you have all the airlines, all the manufacturers cooperate on sustainability like they today cooperate on safety? Right? How do we learn from what has worked and what hasn't worked in the past?
I'll give two very quickly. Well, I say quickly, and then I just keep talking, so it's probably not going to be quick. The first, I'll say, I don't want to say it to be controversial. It's not a full pivot away. It's a pivot to not so soon with hydrogen, right? So I think a year or 2 years ago, there was an extreme focus, certain areas, that it was happening really, really soon. And I think as the conversation broadened to a system-level perspective, and we realized, well, how are you making the hydrogen, right? We talk about net zero, which is a great catchphrase, and it sounds really cool, but net zero where, right? Out of the aircraft, the full ecosystem, what kind of net zero? We can get into that later, but once we started talking about that with hydrogen, then we understood, okay, well, there's all these other pieces that have to come into play, the safety of the fueling, the training, the airports are all of a sudden like, how are we gonna support this? So I think hydrogen still has a role to play. We want to be producing green hydrogen for many different reasons. I think in certain aircraft vehicles, right, shorter, maybe niche markets, it's gonna come in sooner, and that's a great option. But I think it was just sort of a pivot away from it happening 2025, right? 2030, we're getting these aircraft out. And again, I was at a conference where a lot of the people that were focused on the technology of cryogenic hydrogen were saying, well, you know, we can prove the technology works, it's just the safety standards, you know, can we get it certified with the intent that it would eventually meet the safety standards? It's like, no, absolutely not. You come to an airport and you say, you can fly on this traditional aircraft, or you can fly on a hydrogen aircraft that's like pretty safe, but not fully safe today to our current standards, but will be in a few years. That's not gonna happen. So I'll say that one as one. And then the second one, has its cycles, and I definitely worked on it when I was an undergrad. Algae-based fuels, I'll just say that they always have hope. I think that the best explanation that was given to me is that typically the types of algae that produce oil in a way that we need to produce fuels are just genetically weaker, and so as soon as you get another algae strain in there that is stronger, it sort of just takes over. So it sounds good. It looks really good in commercials. I don't know if hopefully you guys haven't put any commercials out. The green vials of things, but it just really hasn't come to fruition. So just keep eating some French fries, but hopefully we can make it some other way from other energy or waste feedstocks. But yeah, algae oil's kind of been my thing.
But I think the punchline here is that this is an iterative journey, right? Like we definitively don't have the answers. We don't know what operating in 2050 is going to look like. And so it requires exploring, iterating, failing fast, pivoting, and keeping safety as a lodestar in addition to sustainability.
Very good.
Yeah, a couple of thoughts that I had on that, and especially when it pertains to algae. So if we look at that, we've had these issues where we've had algal blooms. I'm from Ohio, so we've had them that have formed on Lake Erie because of the phosphorus and fertilizer and other runoff that we've gotten from farming and other industrial sources and things like that. So in cases where we're having that, and I know there's also coastal regions down in Florida that had the red algae. Are there ways that creates an opportunity? Instead of saying we need to have, if we have this occurring because we can't solve that environmental problem right now, but what we can do, can we harvest that and then we can be able to use that as part of the feedstock for sustainable aviation fuel?
Yep.
What's the thought? One of the things that I try to do is I try to look at the challenge, but also opportunities. And so on the space side, I told people on the space side, we said, well, we're going to go to the moon, have a permanent presence, and then we're going to go to Mars, where you're going to have a waste stream of stuff. What are you going to do with that waste stream? Can you come up with a compact bioreactor that allows you now to be able to convert that waste stream into some kind of usable energy? And so we know that problem is going to exist, but what solution do we put forth to help to solve that problem? The second thing is I'm all in on the French fries. My cardiologist might not approve of it, but I'm all in on the French fries. So after this session, we're going to meet up for French fries, and we're going to start us on this path to sustainable aviation fuel.
Where it's at.
Very good. Wonderful. Okay. So this next question, I think, Anna, you're probably a good person to kick this off. And I'll take it and maybe modify it a little bit. So what regulatory and also I would add incentivization structure can be used by the FAA to encourage commercial airlines to take steps towards sustainability? And then Sangita, you're
what can we do to encourage you guys to take steps towards sustainability? I'll take it more from the incentive side. I mean, from a regulatory side, we're typically focused on safety. As Amanda was saying, we have had this shift more towards the environment. There are measures in place. There are different abilities that the FAA has that we could take a closer focus on some of these emissions that the EPA has deemed health hazardous, right? And those are ways that the FAA could start regulating fuel composition as it relates to the contribution of CO2 emissions. But I think from the incentive side, and that's really, again, going back to the win-win, through the Inflation Reduction Act, we actually just had for the first time this new grant program. So it's called FAST, which there are other grant programs called FAST, but it's fueling aviation's sustainable transition. There is a portion of it for low emission aviation technologies, and then there's sort of the majority, 244.5 million, are for projects in the US that are committed to scaling up the production, transportation, storage, or blending of sustainable aviation fuels. So we're actually in the process of reviewing the applications that we've received for that program. But that is a way that we can work closely with industry to actually get that scale up happening. I think other than that, we work closely with the manufacturers through the CLEAN program, so that's our continuous lower energy emissions and noise program. I always like to spell out the acronyms. We use a lot of acronyms across industry, and it's important to know what all of these things mean. And that's really the way that we help mature aircraft technologies that then the airlines can go and hopefully buy and renew their fleet with and contribute to that part of the wedge that Amanda was clearly sort of walking us through. If you all haven't seen it, so there's many different versions of wedge charts. I did just want to highlight that the U.S. Aviation Climate Action Plan, which we released in 2021, we'll be renewing for 2024 because it's our state action plan for ICAO, and so we submit it every 3 years. So you'll be seeing an update to that later this year, but it outlines all of those different wedges and the expectation that we can hope to see that airlines will continue to invest in and make those choices that, again, help reduce their overall fuel burn and fuel usage. So.
Where would we be as an industry? Where would we be as an industry without acronyms? But. Yeah. No, I think you're spot on, and I will say that I think the IRA in particular has been a very important piece of sustainable legislation, and we see that for sure. I think it's the power of and again, right? How do we invest in our fleet and renew that to get the fuel efficiency? How do we, again, signal demand for sustainable aviation fuels while recognizing that it needs to come down the cost curve in order to be economically viable at scale? I think one of the first charts that you put up showed the profitability of airlines, and it is pretty dang hard to do this. So we launched late last year the Minneapolis Coalition in partnership with government, local agriculture, and finance to look at SAF in the Midwest and understand how do we increase demand, how do we make it more economically viable. And I think those are the kind of government industry partnerships that are crucial.
It's I think when we look at it on a global basis, there's two main objectives that are being pursued, and I call one of them the carrot, one of them the stick. Right? In Europe, they're using the stick, that if by certain dates you haven't reduced your efficiency, you're paying a carbon tax.
Right.
And the worst, if you don't improve, the tax goes up year by year by year, right? That's the stick. You're going to improve or you're going to get whacked on the head. Here we're doing a carrot approach. If you produce and use sustainable aviation fuels, you're going to get a tax incentive. So we're going to kind of see what works. Maybe it's both. Maybe it's a combination. But unfortunately, we're going to play out this experiment over time. If we do look back to history, and I'll go back to the 70s when we had the energy crisis, right? All of a sudden, automobile manufacturers were required to produce vehicles with certain mileage efficiencies. And since then, those efficiencies have been pushed up by law, by policy. And this is probably the most controversial, but what if those were applied to aviation, right? All the things we've talked about, the net zero by 2050, the ATAG or the FAA plans and all these things, they're all voluntary. There is no real penalty. There is no particular reason to get to those other than, our shareholders, our investors, our travelers want this to happen. Maybe it's time to put some regulatory force behind it, but that takes society demanding that happens.
Yeah.
And if I could maybe just quickly add on to that, because we talk about the carrot and the stick approach, and I think one important thing to recognize, especially with the SAF market, where is it all going right now? It's going to California, right? California has the California LCFS. It incentivizes, it provides that financial reason for SAF to go to California. So that's one of the things too that we're looking at is, do we have a national LCFS? So there are ways to look at it, and I feel like a blending of the carrot and stick approach could be good. And I also appreciate the fact that there are different ways of approaching the same problem, and sometimes it's good to be in those early stages where the US tries one approach, Europe tries another approach. We can both learn from the challenges and going one way or the other, and then eventually come to a more cohesive solution.
Great. We're going to take a quick pivot away from SAF for just a moment. We'll come back, though. But actually, I have a question for you, Rickey, and I'm sure, Amanda, you're probably going to want to chime in. Something tells me that you're going to want to chime in. So specifically to NASA, what is NASA's view on the use of liquid hydrogen compared to SAF for commercial aircraft?
I'm not sure we have a consistent view on that. I think there's pockets within NASA that believe that both of those are viable paths. There's some people, I think, within NASA that believe that hydrogen isn't mature enough. Those tend to be the people who support the first A in NASA, aeronautics, because we've been working with hydrogen on the space side for years. And so part of what I think we're trying to figure out is, again, what are the appropriate investments in order to make it happen? So when I start looking at hydrogen, I will defer to our friends at the Department of Energy on the production side of that. And they've gotten a lot of resources, especially through the Inflation Reduction Act, when they got a lot of resources to start looking at that and some of the infrastructure work as well. The thing where I think the NASA, where we need to be focusing on is that, again, if we want to go all in on hydrogen, from a materials perspective, is then how compatible is that with existing engine systems? And we know that with hydrogen, when you burn hydrogen, that hydrogen embrittlement is a problem, not only for the metallic parts, but also for the soft goods, for the seals and the other systems inside the engine. So how do we address that? Do we need to come up with not only new material systems, new environmental barrier coating systems? Do we need to come up with new inspections, technology? How do we work with FAA then to be able to say, okay, we're going to certify this, and this because it's flying some new technologies in that propulsion system that's different than what we've done before. What's the inspection schedule need to look like? How often do you need to take it out of service to do the inspection, because hydrogen is different. And so I think that at times, I think for us who are more on the research side, I look at it as an opportunity space. And I think for some of us who may be more on the programmatic side, they may think that the challenge is maybe a little bit insurmountable at this time. But I still think it's something that we don't have a consistent voice on at this point in time. And I know I've been trying to nudge some people to come jump on this hydrogen train with me, because I do think that the opportunity space can be very rich for us to make some significant impacts and breakthroughs.
Yeah, I find it interesting that an odorless, colorless gas has so many different colors.
Yes.
No other gas has that many colors. But when we look at hydrogen, it has to be part of the solution, right? Because for aviation, it's going to be in all of the above. And so hydrogen is going to play. Now, there are absolutely challenges, right? Whether it's in the propulsion side, right, or in the storage and transport side. Today, here just in the US, 11 million metric tons of hydrogen are produced and transported around the country, consumed by vehicles. I think California right now leads with a little over 10,000 electric or hydrogen-powered vehicles, with nearly 100 refueling stations across the state. There's somewhere on the order of 5,000 hydrogen forklifts in use in plants all around the country. And all this hydrogen's moving around, and it's really safe. Why? Because we have experience transporting it in a limited quantity. Is aviation going to move the needle on hydrogen production? Probably not. It's going to be, quite frankly, long-haul trucking that can't electrify because they can't get the range, they can't get the refueling times, and there's, why lug around all that weight? It's going to be hydrogen fuel cell trucks that need high-pressure hydrogen, and that, they need hundreds of millions of metric tons per year. Aviation will kind of piggyback on that. But then, for aviation, becomes the question of, in space, NASA uses, liquid hydrogen tanks, great. 60 plus years of experience doing that for a tank that you fill a couple times and then you throw away. Right? In aviation, you want it to last decades, be refueled on a multi-time per day, be able to stay chilled for months at a time. It's an entirely different material challenge. To say nothing of the volumetric concerns. Now, let's face it, while hydrogen per unit weight is way more efficient than kerosene, that same amount of energy takes up 4 times the volume.
Right.
So now you have a volumetric issue, and volume in aviation is not a good thing. So designing an aircraft to deal with that volumetric issue is going to be a challenge. And it's not retrofitting aircraft. There are companies that are doing that, and I think they're going to blaze the trail, but you lose range, you lose payload, right? And that's what aviation makes its money on. So that clean sheet design that is going to be out there in the future somewhere that we might see it in the late 30s into the 40s. That's going to be that first inroad into a hydrogen-powered aviation that may be gaseous, that possibly could be liquid, but to take care of all the material issues, and it's going to be short range and smaller, but it's going to be clean, right? If the hydrogen is green, that colorless, odorless gas. So there's so many different challenges in hydrogen, and then we start looking at the ground infrastructure and the refueling concerns, and there's been lots of reports, but no airport is going to commit to putting this into their planning concepts until there is a commitment from an airline to operate a vehicle that is yet to be defined from that airport on routes that are still uncertain.
That's right.
How do you plan for a future where you have no idea what it looks like? When you have to make those decisions today. That is the challenge, and that's why it has to be an all of the above to find what are the solutions that are going to work and not end up in the museum of failures.
And I think the all of the above, just to underscore, includes infrastructure, includes workforce, in addition to the technology itself. And that's something that we need to do.
So related to workforce, we'll come back then to the SAF questions after this one, but looking at kind of where things are as far as sustainable aviation is concerned, there's very much a parallel revolution happening right now in AI, machine learning, digital engineering, autonomy, lots of advanced tools and capabilities, that kind of transcend multiple sectors. How can we use these tools, develop new technologies and approaches to develop a growing aviation ecosystem sustainably?
Well, I think I'd even go beyond that. I mean, we're not the cool kid on the block anymore, right? People coming out of universities are thinking about all those things, and I want to get into that business, and they're not thinking about aerospace anymore and aviation. So how do we say you can work on all those unique all those capabilities, and how do you apply them to the problems that the aerospace industry is going to be facing? And to get those, if you're out there, right, those younger generation who are going to be working in these fields, I know that some of you are there today, but how do you bring that back to your university and say, you know what, I was at an aerospace conference, and I know we're in the quantum engineering department. Let's figure out how to solve something, how to apply AI to some of these problems? How do we understand unintended consequences better using techniques and capabilities that are being developed today so that we don't end up in some of these problems that were started, 100 years ago in the industrial age, right?
I'll give a perfect example of an optimization use case that's perfect for AI. We've talked about slowing down the airplane just a little bit, right? And if you had an optimization engine built into some of your flight planning tools that could tell you, hey, this flight's about to come in a couple minutes early, pilot slow down, or hey, route around this place because this airspace, because it's less turbulent, but you're gonna be more efficient, and you're gonna, there are so many variables that we are considering when we're making daily operating decisions. That is a perfect place for decision science to help.
Very good.
And I think from a workforce perspective, one of the things that we really need to do is to be able to communicate, especially to students, that AI and machine learning and some of these other technologies, that's another tool in the toolbox. It's not something that's discrete by itself. I remember I'm a mechanical engineer by trade, and one of the things I used to hate was taking electrical classes. So I remember when I took circuits, right? And it goes back to me probably in my childhood when I was trying to rewire my electric train and almost burnt the house down. And so, when it came down to engineering, it's like anything that, has electric current, I'm gonna push it off to the side. But then when I got to NASA, and especially when I started doing a lot of research work and testing in wind tunnels and test facilities and like that, you get all these different electrical components there, the data acquisition systems, all these other things, and I'm sitting here was like, well, maybe I should have thought a little bit better of my circus class than what I actually did, because now I'm utilizing all this. But that was actually a tool that was being put in my toolbox, but I really didn't understand how I would use that tool. And so I think that part of what our responsibility is to be able to communicate, especially to young people who may have interest and who definitely have the aptitude in machine learning and AI and some of these other emerging technologies, is that, hey, that has a place in aerospace as well. It's just not something that's discrete and by itself.
Wonderful. Yeah, very good. So I want to talk a little bit about SAF now. The drop-in nature of it is very appealing, right? We've got a $1 trillion infrastructure, right, that we've developed over many, many decades, and fleets of aircraft and technologies that operate off of kerosenes. But the acknowledgement, I guess, that has to be made is, well, not all SAFs are created equal, right? The life cycle impacts of them can vary broadly, and some of them might even be counterproductive towards sustainability goals. So given the fact that almost exclusively these pathways physically cannot fully eliminate, let's say, net greenhouse gas emissions, what's then the relevancy of SAF as a pathway for the future? We don't avoid controversy here. But.
Yeah. I think so. When you look at those wedge charts, you see the option space between the two options that it's really given, at least in the wedge chart that we usually show, is SAF with a 50% life cycle reduction and SAF with a 100% life cycle reduction. We don't talk about SAFs that are less than that, right? But there are SAFs that are less than that. That's why I think generally when we talk about sustainable aviation fuels, I usually try to caveat it with however you want to define sustainability. That first S of SAF is really going to depend on the program you're operating under, the scheme you're trying to qualify for, whether it's a tax incentive. CORSIA, for example, is part of ICAO. It's the Carbon Offsetting Reduction Scheme for International Aviation. The CORSIA eligible fuels for that, you only need to have a 10% reduction to qualify. 10% is not going to get us there. 10% for operational improvements would be great. But if you're looking at that wedge chart, SAF is such a significant portion that we really need to be focusing on 50%, 75%, reduction or greater. And so I think there is still that question of, well, we're still using carbon as part of the life cycle. It's still emitting CO2, But overall, as if we're drawing down more carbon from the atmosphere, carbon dioxide from the atmosphere, carbon sequestration, we talk about CCS, we talk about some of these pathways when you're talking to the corn farmers, the ethanol producers. In order to bring their life cycle carbon intensity down, they need to be doing things like utilizing waste CO2 and sequestering it. But that seems like an easy solution, but now we're running to challenges across the Midwest of people don't want to have the CO2 pipelines going through their backyard. Not every ethanol facility is located on a geological formation that's optimal for sequestering CO2. So sometimes, and it's also better to just sort of pull it all together and ship it to an area where it is optimal to sequester it. But where do you put those pipelines now becomes a really big issue and a really big challenge. So I think there's the opportunity for SAF to be a significant portion of that wedge chart, but we still need to have those other reductions come in. There are out-of-sector offsets. Sometimes people don't like to talk about offsets. Those are things that we can also ensure that help the aviation sector decarbonize additionally. It's not easy. I think that's why hydrogen does need to come in at some point in the future. It's just how quickly can we do it, and not waiting for that perfect solution and taking steps now to start putting us on the path, like the Delta slide sort of outlined that trajectory to 2050. So I think overall we're just continuing to push how far we can go with those life cycle reductions, really trying to incentivize and encourage producers to go for those drastic reductions. In the SAF Grand Challenge, we have this sort of 3 priorities, enhancing the sustainability, expanding the supply, and reducing the cost. And people say, well, which is the top priority? It's tough to say, well, we want to do all of those things, right? But it's really going to be a mix, right? You're going to have some fuels that have greater carbon intensity reductions, but they might not be at a huge supply and they might be really expensive. Then you'll have other ones that are more affordable but don't have the reductions that you need. So I think as long as we keep pushing towards those significant carbon reductions, we'll continue to get the technologies in place that we need to make sure that we can go more from that 50% life cycle reduction wedge to that 100% reduction life cycle wedge.
Yeah, I agree. I think, I said this at the start, but what we fly, how we fly, the fuel we use, those are all equally important things to consider, but you can't understate the importance of SAF as part of that 2050 plan, and it is the largest wedge on that chart. I think that's where exploring those other pathways, whether it's alcohol to jet, power to liquid, to give it the impact that it needs is important. And
I did want to add too that we talk about cost, and SAF is expensive. We understand fuel costs are a major part of airlines' overall costs. But what Amanda was saying earlier that I think is really important is, and you saw in the clip from Delta, is like the climate is changing and that is having a cost. And we keep sort of batting around of like, what is the cost to society of the climate changing? And until we start putting that cost and valorizing the penalty that we're paying right now, we're not going to truly understand the value of these decarbonization strategies. So they're always going to seem extremely expensive. But if you're starting to take into account the severe weather, the extreme weather events that are causing all of these drastic floods and droughts and causing famine across the world, all of these things, once we actually start putting the value behind those things, then we'll understand the value of these options that we have. So
yeah. And get consensus, and again, partnership
get consensus,
around those.
Yeah.
I'll also say one of my favorite, life mottos is progress over perfection. And we don't have perfect solutions today, but that doesn't mean we shouldn't be making progress in the right direction.
SAF is going to be part of this, has to be part of the solution going to 2050, because when we talk about electrification, we talk about hydrogen, we talk about other fuels, there's no way that they're going to have a significant impact by 2050. I mean, they're going to have a chunk of that sand chart, lasagna chart, whatever you want to call it, chart. But today's aircraft are going to be flying in 2050, right? Long-range aircraft, that can fly transatlantic or transcontinental are going to be using SAF. for all the foreseeable future, because these new technologies won't have the range initially, maybe 50 or years from now, but SAF's going to be part of it. So when you look at CORSIA, there's 7 or 8 now approved ways to produce SAF. And each of them have different, if you look at the back cycle of not only what is the feedstock, but what is the energy impact of actually producing that sustainable aviation fuel, they vary. And all the byproducts in the fuel themselves are different, so they react differently with the engines of today, with the potential engines of tomorrow. And CORSIA is, I think, looking at another dozen or maybe 15 other ways to produce SAF. And so how to evaluate all of those to say, not only what is feasible, let's look at everything, but then how do we sift that down to what is going to be the several that are going to be the solutions, because feedstock's going to be different across the globe. Capabilities of availability of energy are going to be different around the globe. So how do you narrow it down to the ones that are going to have the least, not only environmental, but societal impact? And that's something that's going to have to be worked out. We say SAF and make it sound like there's one, and there's dozens.
Right.
Very good. Well, I guess related to SAF then, and we covered a little bit about, well, how do we trade the, let's say, environmental impacts and the cost, and maybe there's not like a Goldilocks solution, it would seem, at this day and age. But assuming that there's going to be higher costs, specifically for you, Sangita, are airlines willing to accept the higher fuel costs with SAF? Is it primarily a cost issue, or is it a supply issue, or both? And will consumers be the ones who foot the bill at the end of the day?
Yeah, what is the economic model today and what's the economic model in 2050? I think they're going to be different. But I think right now, we want to see SAF in the market. And so we are paying a premium for that SAF. And we've publicly stated we want 10% of our fuel to be SAF by 2030. That fuel will cost a premium. I think multiple people have alluded to this. What's the opportunity cost of not having SAF? I think that changes the equation. Whether consumers pay for this ultimately or not, we'll see. What I will say is that we have seen a lot of corporate demand for sustainable aviation fuel, and that's a really exciting space to play in right now.
Sounds like we need some carrots.
Well, and going back to what Rickey was saying before about budgets reflect your values, right? We all say we want sustainability. How many people actually opt in, right? I'm not saying we have to pass the full cost on to customers, but at the end of the day, programs that are enacted through taxes are having everyone pay for these things, right? So even the people that aren't flying. So if you're flying a lot, yeah, why shouldn't you? Yep. And if you're saying, yes, let's do the sustainability, why aren't you opting into those things? I think the statistics have been changing. I think more people have been opting into those things, but maybe it was 2-ish years ago, the CEO of Lufthansa was doing an opening keynote in Munich, and he noted that it was 50% of the German citizens say that they are in green views or they support green views, and he noted that less than 1% of their customers were actually opting into this option that they have. I did learn some interesting psychological tidbit that people are generally less likely to opt out of something than to opt in. So I've started to see some things where it's like you have to select, deny, do not do this if it's automatically applied. But I'm just saying there are ways, and I do think at some point, if it is something that you value, are you actually putting resources, monetary time, energy behind that? We do that the same with our personal lives. You say you want to do this, you say you want to read a bunch of books. Are you actually spending time reading the books, right? So if we say it, we need to actually mean it. We need to demonstrate it through the actions that we take on a daily basis.
I think there's also a huge education component that we're still working through. So how do we, again, right now the focus is corporate customers, but how do we educate the flying public on what sustainable aviation actually means, what cost that comes at, and what role everyone should be playing in the ecosystem?
And I think this tees us up for our last question. So we're at the last couple minutes here of today's session. This is kind of a nice way to think about the future. So I'm kind of looking around here at the audience, and I think I see like 1 or 2 open seats over there. I guess where I'm getting at is the question here from the audience is, how do we garner interest? How do we get more people into this room, let's say, to hear and care about this type of problem? What can we do with engaging to set everyone up to understand and recognize and value what we're doing here?
As I said, we act through our daily actions. We set an example. I really hope that if you guys care about sustainability, not only do you care about it, but you talk about it with your family, with your friends, and that maybe even your family and your friends can go off and talk about sustainability the way that you do. I always love it when I overhear my mom or my brother or other family members or friends talking about the work that I do, and they generally get things right. And that's important because that means that I'm actually communicating the things that I'm doing and why I care about it. I mean, honestly, this opening video from Delta almost made me emotional because I truly love aviation. I used this story before. It might be getting old, but I think it's still new enough. I'm here because of aviation. My parents actually met at O'Hare. My mom worked for Alitalia, and my dad traveled a lot, and so that was how they met, and that's why I'm here. And my dad worked in aerospace, and he built the machines that make the planes that we fly on. So it's really important to me, but at the same time, I grew up with an appreciation for the environment and for respecting the planet, for respecting all living creatures, big and small, that are part of this planet. And so I think it's really important that if this is something important to you, and maybe it's not, and that's okay. It's good to have different priorities, right? We need to have people, we say, are we on the same page? Let's be in the same book. We can be on different pages, but like, we all can have our different priorities, but if it is something you care about, not only should you be speaking about it, but the people that you are very close to, they should know about it, and they should be sharing it, because then we can multiply that effect.
I completely agree with that. You know, Delta, we're about to celebrate our 100-year anniversary next year. 100 years. But I think the fact of the matter is, if we want to be an airline for another 100 years, we have to solve this problem. And that's something that should resonate with everybody at this conference, whether you care about the planet or not, right? Like if you care about aviation as an industry, we have to solve this.
When I think about this, I think one of the things that we have to do is not only talk about the scope and magnitude of the problem, which we need to do so we can get people's attention, but we also need to show them some optimism about the opportunity space that exists if we solve these problems. If we, for example, if we increase power density significantly for a battery that we use for aviation, it can have impact on automotive, can also have an impact on terrestrial power. So we can make our power grids more resilient to weather events and challenges and things like that. So we always, so I would always stress that we not only talk about the challenge, but also talk about the opportunity that exists because of that challenge, if we're willing to look for what that opportunity is.
Well, I think they should attend the Sustainable Aviation Working Group this afternoon to talk about some of these potential solutions. So put that plug out there.
Yeah, which, by the way, is happening 4 to 6 p.m. in one of the Bay Hill rooms, I believe. You can check in your program. There's a list of technical committees and other meetings related there, so that's where you can find the information about that meeting. Well, hopefully that gets you fired up, right? I mean, that's kind of what we're here to do. So now you've heard it here first. So thank you so much for coming to this session. I have really enjoyed the discussion, learned a lot from my colleagues here, and hopefully you have too. So looking forward to a great rest of the week, and take care.